In this video we will discuss the photon properties and its importance for the modern science. Light is a phenomenon that has been hard to describe since the beginning of the scientific knowledge. We start our analysis with Christian Huygens. He created the first theoretical analysis of light and proposed that light is actually a wave. Later, Newton proposed that light is a stream of particles, although he did not show any evidence of his statement. Thomas Young provided a definitive proof that light is a wave, by using light interference properties, at the beginning of the 19th century. In the late 19th century, Maxwell also proved that light is a wave of a very specific kind, the so-called electromagnetic wave. Furthermore, Maxwell proved that the visible light is only a tiny fraction of the electromagnetic spectrum. But at the beginning of the 20th century, Einstein showed that light is a particle, by proposing a model that explained the photoelectric effect. Then it is natural to ask, who was right about the nature of light? The answer is not simple at all. Actually, light behaves as wave and particle, depending on the experimental conditions. For example, light diffracts and interferes, but at the same time extracts electrons from a photoelectrode. This property is called the wave-particle duality. As we are very familiar with the wave behavior of light, we are going to focus in its particle behavior. As you may know, Lewis proposed the name of photon to make reference to Einstein light quantum. Let's enumerate some of the properties of the photon. A photon is a fundamental particle, indivisible, and whose energy is released in integer packets. In addition, the photon has rest mass equal to 0, propagates at speed c, and neutral electric charge. Depicting an image is always a good way to understand the nature of a phenomenon in physics. However, there is no simple image of a photon. But, for our purposes, we will depict the image of the so-called wave packet. This representation allows us to understand the photon as a particle as well as a wave. On the other hand, we can calculate the momentum of a photon. We know that special relativity set the total energy of an object is following. With a rest mass of 0, then we have. From the last equation, we can see that. Also, using the relationship between the energy and frequency discovered by Planck, then we have. Finally, using the definition of the speed of a wave, we finally get. If we consider that the momentum should be a vector, then we can use the definition of wave vector as follows. Then, we get the vector representation of the momentum of a photon. Note how the momentum is imparted in the direction of the propagation of the electromagnetic wave. An interesting result that suggests that light can move objects. In the last equation, we found a new constant called h bar. And it is simply the Planck's constant divided by 2 pi. This constant will appear very often when we study the quantum mechanics principles. On the other hand, it is important to know that light is one of the pillars of modern science and technology, in any of its forms. For example, the semiconductors that are used in the electronics of your computer or smartphone use electromagnetic interactions, mediated by photons. The next generation of computers are the so-called optical computers. These will use only light, and will perform operations faster and more efficiently than modern electronics. Moreover, the holy grail of the computing sciences is the so-called quantum computing. Even when nowadays it is made by ultra-cold atoms, in the future it will be possible by using optical systems. Finally, it is important to know that the most amazing property of light is that it can be treated as a classical phenomenon by using the Maxwell's equations. But at the same time, photons have quantum properties due to their intrinsic characteristics due to the wave-particle duality. We will work on this in a future video. Stay tuned.